Hello, my name is Nguyen, and the topic for my semester research project for Intro to Suite is how machine learning optimizes cloud networking. Now, for the project formulation, I referenced chapter 5 of the Somerville textbook, since that's the one that talks about cloud networks. And in that, the author says cloud servers that you can rent can be started up and shut down as demand changes. This means that software that runs on the cloud can be scalable, elastic, and resilient. And since cloud systems rely on these three characteristics, machine learning is presented an opportunity as the ability to evolve and adapt to ever changing conditions relates really well to how cloud networks are meant to also adapt to ever changing conditions. This infographic will basically just cover ML applications of cloud networking, how it's used in current platforms, and just a baseline understanding of its role in cloud networking. But it will not cover ML in non cloud networking systems or how other types of AI is used in cloud networking. Now, for the literature search, you can see that my references is quite extensive. So I did a lot of research, but three that I want to highlight are from the Journal of Internet Services and Applications, the Journal of King Saud University, and the 30th International Symposium on the Modeling, Analysis, and Simulation of Computer and Telecommunication Systems. And these basically all talk about how the recent use of ML in networking has been quite significant, whether it's through improving cloud system resilience, reducing operational costs, or just sending information back and forth with minimal latency, and how it still provides significant performance gains, even for large scale cloud systems. And for the critical analysis, I'll just first like to mention how ML integration has provided a 38% faster response time to network failures, 32% enhancement in resource utilization, and 26% decrease in operational costs. The pros include predictive resource management, dynamic network optimization, threat detection, and elasticity. The cons include complexity, privacy, resource usage, and latency. Now, some companies that already use ML in their cloud networking platforms are Google, Amazon, Microsoft, Meta, and Cisco. I'm sure you've heard about all of these. And I think ML is significant, especially since you can see that the number of not man, machine to machine connections grows by the billions each year at an increasing rate. And some of the most interesting things I found were how Amazon Web Services, despite only accounting for a fifth of Amazon's total revenue, controls one third of the cloud computing market, and how specifically just for Prime Day, 80,000 custom AI chips were deployed in one day just to handle the activity surges on the Amazon website. And for the evaluation, I would just like to say that with the explosive growth and integration of AI across the globe, we often forget about the applications of AI in the industry, and instead sensationalize the novelties of AI more accessible to the public, such as ChatGPT and other forms of generative AI. However, however, the advent of machine learning has certainly disrupted global industries, especially in cloud networking and computing. We see significant improvements to cloud networking systems as time goes on. Throughout this research project, I've noticed that all my sources were published within the last 10 years, and the majority of them were published within the last 5 years. Actually, only one of them was published before 2020. And it truly showcases how machine learning quickly found a place in cloud networking. And I think the use cases for ML in cloud networking were quite easily digestible, as ML is used to predict road traffic and optimize GPS routes in real life. And with how the amount of connections increases by the billions each year, I am excited to see how machine learning will grow and adapt to the ever-changing internet landscape. And here are my references. I'll just scan through them so you can see. Um, so yeah, and this is the whole graphic. And thank you for listening.